Okay, you guys, I'm ready when you are.
Okay, let's do it.
This is September the 16th. This is a test on finely ground wood on the cone burner.
Still leaking, kid? Still leaking?
Okay, they're beginning to put the flame wood into the burner.
You didn't put the course foot back in, did you?
I can stop now. Might as well stop.
Yeah.
Okay, here we go again with a flame utilizing finely ground wood. a little better.
Yeah, basically, burner fine.
Okay, make burner fine tuning with what, the air? Moving the nozzle position. Looking better and better. Zoom in on it, see what it looks like. Really looking much better.
Yeah. Not all of that.
Sound you hear in the background is the vibratory feeder feeding the wood out of the tank through a vibratory screw feeder. Then this still distributes it into the primary air. What's the oxygen level of this thing? This is the 3 million BTU furnace. Look right in that porthole, will you, Carl, please? This is where we've been viewing. Now frying wood only. Okay, we have 100% wood only. What temperature are we at, Fred?
1338.
1338. What's the stack look?
3/4 of a million BTUs.
3/4 BTUs, and what else?
About 6% oxygen.
6% oxygen. Make it particle size expand. Hard to believe. What does it look like outside? Outside here. Get the front end, so I'll need those lights.
Putting them off the floor now, it's not like it was. Temperature's coming back.
The Zurn Energy Division truck. Oh, Fred! Randy! There we go. Come on out a minute. Come on. All right. There we go. All right. Now we'll go inside. Front end looking at the... All right. Tell me what you're doing, Fred.
Trying to zero the sulfur dioxide here.
Okay. And what meter is that? Now, please.
Oxygen.
All right.
It's coming down rapidly because he just reestablished the wood fire. Carbon monoxide,
What is that reading right now?
73 parts per million.
That's good or bad?
That's very good.
All right. I'm looking at the oxygen content coming down, right?
Right. The wood will
Background,
burn.
you can hear the wood screw going in. Okay, what else should I be looking at here?
The wood will normally be burning at 3 to 4% oxygen.
All right, anything else?
We've got the backup oxygen and carbon monoxide below it as a cross-check on the other instrument. They're reading essentially the same numbers.
Okay. What is that?
That's the oxygen. It's reading 6.5 compared to 5.5. This one's a lot slower.
Outside, taking a look at the stack gases coming off of the bark fire. You can see absolutely nothing coming out of that stack. You can hear the exhaust gases in the background. What's the outlet temperature, Fred?
About 1,200 degrees.
Randy, would you pick some more material up with your fingers, please? Pick up some more material with your fingers.
It's a single register burner set up with a natural gas ring and a solid fuel center nozzle. The burner can be set for either clockwise or counterclockwise rotation, and the solid fuel nozzles are replaceable. It has a FireEye flame scanner and a spark to ignite the natural gas. There's a secondary flame scanner in the side of the furnace for backup monitoring. The natural gas is metered and controlled manually. The airflow is controlled manually but is not metered.
Tell me what I'm looking at.
It's a wood fire, about 3/4 of a million BTUs an hour, running with ambient temperature primary and secondary air. This burner is rated at 3 million BTUs an hour, so we're well down on its turn down curve.
How do we account for the flame now looking perfect?
Okay, I have a theory.
Right now, wait a second. Let me.
Okay, the wood was stored over the weekend, and I think that the top layer of wood absorbed enough moisture to make the difference. Because when that first layer of wood was run through the system, the fires got better. Temperatures are about the same, operating conditions are the same. Had to be a change in fuel.
Now when I zoom in and look right at the flame, I can see some sparklers because now I zoom all the way down and look right at the end of the burner. That's what I'm going to do right now. We can see the sparklers coming right off the end of the flame itself. But we know they don't make them out of the furnace. So when I zoom back now, you'll find that those sparklers absolutely disappear because now we're looking at the back end of the furnace instead of straight in at the flame itself.
There'll always be some sparklers associated with wood firing.
I'll take this at various locations, various depths. Now we're looking at the flame a little closer, so maybe we can spot some design changes we might want in the burner itself. Now, at the throat of the flame itself, we're looking right at the throat of the flame, right where the swirl takes place.
You got it.
All right. Notice a pretty round and concentric swirl.
What do you see, Brad? The swirl from the air is very pronounced. There's some tearing of the flame right at the nozzle itself. I would like to try putting a little bit of spin on the primary air in order to distribute the fuel a little bit better.
Yeah, that's 1390.
There's some material being carried down from the flame, but it's minimal at this point.
All right, now as we back up from that flame, start looking at the back end of the burner itself.
You can still see a little bit of tearing around the nozzle itself.
It's in the case. Tell me what I'm looking at.
Okay. I'm not exactly sure at this moment.
Okay, we have now begun running on coal. We've concluded the wood test, and now we're running coal that is 80% minus 200 mesh. Go ahead, Fred. Go ahead. Tell me what you see.
The coal is running at the minimum stable fire we can get in the furnace because of temperature limitations. The fire is completely stable, filling the entire throat. This picture right now has a small clinker in the bottom of the throat that developed because the nozzle was too far back. It's slowly burning out. The SO2 with this coal is running about 1,600 parts per million, and we're at about 6% oxygen.
Refuse the comment.
Okay, we're going to zoom up a little closer and see if we can't move in on the picture.
Clinker is gone from the throat. And the bottom of the fire is filled out.
What's the temperature of the exit gases? About 1,400 degrees Fahrenheit. Is that a good looking flame for me?
Yeah, that's a good flame. Looks a little hazy because of the ash content.
Can you tell me something about the coal we're burning?
The high sulfur Illinois number 6.
Illinois number 6 coal with what do you think the sulfur content is?
3.5, approximately.
3.5. All right, we're going to go a little closer towards the flame now. And I'm going to focus in on the near end of the thing.
Furnace temperature is 1525. It is. Yeah, wherever it comes and goes, goes in and out on you, pulsates. Yeah, that's good. The only problem we've got is temperature. We can't turn it down anymore. That's minimum hole flow. We'll have to run with higher excess air than we really like. Let's take a couple of sets of data.
Walk over there. Tell me what's going on. Aha. You're not kidding, are you?
No, that sulfur is strong, fella.
Okay. This is the output from the furnace. Tell me, what do you see, if anything? You don't have to stand there, just tell me what you're looking at.
Looking at fly ash.
Can you see the ash coming off?
And a lot of sulfur.
Okay, what percent sulfur?
3.5% coal. 1600 ppm would be about a 0.15% in the gas.
Okay, would you say the combustion looks fairly decent?
Yes, combustion is excellent. The ash is a light grayish tan color, indicating complete carbon burnout. There's no pulsations at all in the fly ash or in the exhaust, so the fire is very stable.
What we've got here, then. Go ahead.
Okay, the top line is carbon monoxide. It's beginning to creep up now because I just put it on calibrate. It's been running essentially 0.
All right.
The middle line is oxygen. It's running between 9 and 10%. The dip was caused by a range change for calibrate. Bottom line is sulfur dioxide, running between 15 and 1600 parts per million.
And is that normal?
Those are normal readings for this coal, yes.
And we hope that by the introduction of limestone, we get that to drop.
Yes, we'd like to get a 90% reduction in sulfur dioxide.
Can you tell me what the finest the limestone is?
90 minus 200 mesh.
We're feeding it 90 minus 200 mesh limestone. And at what rate are we feeding it in? What feed rate?
9 pounds an hour. Limestone, 150 pounds an hour of coal.
Nine pounds an hour of limestone and 150 pounds an hour of coal. Go ahead and walk in and clean it. Okay, can you tell me what the feed rate is now?
42 pounds. 150 pounds of coal an hour.
Okay, we're feeding 152 pounds an hour of coal, and we're feeding 42 pounds an hour of limestone.
Down to 450.
Okay, I'm being told that we are down to 450, and at the present time, we are feeding how many pounds an hour?
I'd have to look at the chart.
We're feeding 81 pounds an hour of limestone, and how much coal? 150 pounds an hour of coal. We have reduced the sulfur content by 2/3. Okay, tell me what you're doing, Mark. You're mumbling.
Checking the calibration of the instrument.
Okay. All right, Fred, what do you find that the calibration went down to? What did it finally get down to?
We got readings as low as 130 parts per million. Sulfur dioxide.
At what feed rate on the limestone? Versus 150. 90 pounds an hour versus 150 on the coal.
Correct.
All right, Mark, can we take a look at that?
All right, Mark, what am I looking at now? This is the calibration section.
Clean check valve.
Yeah, let me,
You need the 9/16 screwdriver.
the test data where it's been going down steadily.
All right, you point out which part is which.
This is SO2. See it, it's coming down.
Stand by.
It's 1047,
Stand by.
1022, 468, 190, 130. It's continuously going down.
So as we up the increase of the limestone,
It just
the SO2 drops.
progressively.
All right, thank you.